If I give the phi value constant and if I do not give the r value and theta value, we have to take the full range of r and full range of theta, then this phi is actually similar to whatever the phi we have seen in the cylindrical coordinate systems, rho phi z is there, that phi is this phi only. That is nothing but it is representing a plane having the angle phi from the xz plane. So, phi is actually taken from 0 to 2 pi. So, it is like a plane surface we can able to draw. So, if I give this r, theta, phi, 3 values if I give, already we have understood that a circular line is created because of the r and theta. That circular line is intersected by this particular plane formed by phi value. The intersection of this phi is equal to constant plane and the circular line which is created because of the r constant and theta constant is providing a point, that is our r theta phi. In this manner we are representing the point in the free space. So, r is equal to constant is sphere, theta is equal to constant is a conical surface. Conical surface vertex is at the origin and that angle should be measured from the z axis, theta is measured from the z axis and phi is equal to constant means already we know that one. Now, about theta we will discuss more. Theta is actually the angle measured from the z axis, already I said that one. If I give theta is equal to 30 degrees, from the z axis 30 degrees we have to take and we have to rotate that particular angle. So, this side also 30 we will get, one cone will be created. So, this is extending like this. With this information, if I give r value also, we can able to draw a circle, this is sorry we can draw a sphere, that sphere and this cone both are intersecting, as I said previously here circular line is created. If I increase the theta value, then you will be having this much amount of angle from the z axis and this side also we have to take same angle. Now, that particular cone is intersecting the sphere in this particular region, one circular line is created. That means by varying the phi value, by varying the theta value, you are coming from top to down on that particular sphere. So, if I take theta is equal to 90 from the z axis, this is the 90. So, this side also 90, that means this xy plane will be created. Theta is equal to 90 is nothing but xy plane, that is actually azimuthal plane, it is y axis, it is x axis, z axis. Now, similarly I am taking one more diagram. Now, if I take theta is greater than 90, this is the theta 120 degrees I have taken. So, this side also we have to take. Now, this conical surface is intersecting the sphere here, that means on the sphere we are getting these circular lines because of the different theta values. By having the different theta values with a fixed r value, we are getting this type of structure. It is actually circle. On the sphere we have drawn the circle like this. Okay. So, we can able to move on this particular sphere, we can able to move from top to bottom by changing the value of the theta. One thing you observe here, theta is 0 exactly on the z axis, theta is 30, theta is 45, theta is 60, theta is 90, theta is 120, 170, 180. There is no requirement to take the theta beyond 180 because the values of theta from 0 to 180 itself is covering this left side part also. So, that theta ranges from 0 to 180 degrees. In case of radians, 0 radians to pi radians, but phi ranges from 0 to 2 pi or 0 to 360 degrees, theta ranges from 0 to pi only, that is the thing we have to remember. And r is again radius of the sphere, so radius cannot be taken negative. So, r ranges from 0 to infinity like rho range in case of the cylindrical coordinate system, and anyway phi is 0 to 360 degrees. Okay. So, this is the thing. Now, if you observe this particular diagram, by having the r value we can draw a sphere and theta is measured from the z axis, theta is taken, and if you take the projection of this particular point onto the xy plane, it is intersecting at one particular point, that point is making some line like this, if you make a line, that line is making this particular phi angle with the xz plane, or from the x axis we can able to take that one. So, in this manner we are representing the point in the free space. So, as I said previously, if r is constant and theta is constant, we will be having a cone, sorry, if r is constant and theta is constant, here phi is changing, and r is equal constant is nothing but sphere, and theta is constant means a conical surface. As I said previously, we will get a circular line, and theta is constant, phi is constant. Theta is constant means a conical surface we will get, phi is constant means a plane rotating around the z axis we will get. Those two are intersected means we will get this type of line we will get. Whatever we have indicated here, that type of line we can able to get due to the theta is constant and phi is constant. And if you take r is constant, that is sphere, and phi is constant, that is a plane rotating around the z axis. So, if you take these two, we will be having a line like this. Okay, that is the thing. Next, if you travel along the r direction, that means AR direction, what is the differential length you will get? dr you will get, and r is the distance. So, dl bar is equal to simply dr AR cap only, that is the radial direction, that is a displacement vector we can able to take. If you travel along theta, that is the angle, so you will not be having the differential length vector d theta a theta cap. In addition to d theta, we should have some scaling factor, like in case of the cylindrical coordinate system, when you have the change in phi, how you are getting rho as a scaling factor. Rho d phi a phi cap is the differential length vector, at that time we have seen. Similarly, here if you travel along the theta direction, then you will be having the differential length vector is not only the d theta a theta cap, you will be having r d theta a theta. The reason is same thing what we have seen in case of the cylindrical coordinate system. And if you travel along the phi direction, here also scaling factor is there, that is r sin theta d phi a phi cap, that is the thing. Okay. So, in order to understand that one, here I will take one diagram, that is x axis, y axis, z axis. I have given r value, so that this is the radius of the sphere and this is the theta value, and because of these two we will be having a circular line on the sphere. That line off of that line I am taking like this, and this is the z, and this is actually equivalent to rho. Okay, this rho, this is the rho, and parallel to that one here I have drawn this one. This is actually we are seeing like this, these two are actually same. Okay. So, it is a right angle triangle, so we can apply trigonometric functions in that particular triangle. So, cos theta is equal to, adjacent side is z, so z by r is the hypotenuse, and sin theta is equal to rho by r, so that we can able to tell z is equal to r cos theta and rho is equal to r sin theta. And we have the relations like this, rho is equal to square root of x square plus y square, and in this case because it is a right angle triangle, using the Pythagoras rule, r is equal to square root of rho square plus z square. But rho is nothing but, we know already rho square is nothing but x square plus y square. So, we will be having like this x square plus y square plus z square, and theta is equal to, from this we can able to give tan inverse of opposite by adjacent, and write rho in terms of the x and y, tan inverse of square root of x square plus y square by z. Otherwise, in terms of cos also we can able to write. Next, phi is same thing what we have in the cylindrical, that is tan inverse of y by x. So, this is a conversion from Cartesian to spherical. and spherical to Cartesian is also possible. R is x is nothing but what we need to take here, already we know x is equal to rho cos phi, y is equal to rho sin phi, z is equal to z. This is actually we have seen from cylindrical to Cartesian, and now we have rho is equal to r sin theta, here already we got that one. So, r sin theta cos phi, here y is equal to r sin theta sin phi, and z is equal to r cos theta. It is a conversion from spherical to Cartesian. So, these things we have done. Okay. Then if you observe here, when r is changing, it is travelling in the radial direction only. So, it is a distance, so that if r is changing, the differential length vector is given by dr ar cap. But when you change the theta, then what is the differential length vector is nothing but, in addition to d theta a theta cap, you will be having the r, because whenever angle is changing, you need to concentrate on different arc length, how much change you are observing in the arc length. So, here arc length is given by r d theta, and if you change the phi value, what is the differential length vector is nothing but, again arc length we have to take, change in arc length, that is r sin theta d phi a phi cap. So, here phi is actually like this, phi 1, you are taking another phi, that is phi 2, this is a change in phi, that is phi d phi, it is related to this length, that means rho is equal to what, r sin theta. So, if you change the phi value, what is the arc is affecting, r sin theta is affecting, that rho is affecting. So, that will be the scaling factor we have to consider. When you change the theta value, r is the arc length, that is having the scaling factor r. It is as similar to in case of the cylindrical coordinate system. If you change the phi, what is the arc length we are getting there, rho d phi. Here if you change the theta, r d theta is the change in the arc length. If you change the phi here, r sin theta is the arc length, that is the thing. These things we have to remember. Accordingly, we can able to write differential surfaces also. So, spherical surface, now we are going to talk about the spherical surface. Spherical surface, if you consider, this is created because of r is equal to constant. R is constant means theta is changing and phi is changing. So, spherical surface area ds and its direction is perpendicular to the surface, that is in the radial direction, that means here you will be having ar cap. So, the surface has been created because of the changes in theta, that means when theta is changing, what is the differential length we have to consider, r d theta, and phi is also changing, that means r sin theta d phi. So, totally we will get that particular spherical surface ds bar is equal to r square sin theta d theta d phi ar cap. Now, if you are interested in the conical surface is actually due to theta is equal to constant. Theta is equal to constant means r is changing and phi is changing. If r is changing, differential length is dr. If phi is changing, differential length is r sin theta d phi. So, ds conical surface is nothing but its direction is along theta direction, it is equal to, due to the product of the differential lengths dr and r sin theta d phi, we will get the conical surface and direction is a theta cap. Similarly, you can able to take ds phi also, that is due to the changes in r and theta. So, like this differential surfaces will be created, and we can able to have differential volume. Differential volume is created due to the multiplication of the three differential lengths dr, r d theta and r sin theta d phi. If you multiply these three, you will be having the differential volume. And actually in this particular slide I have given surface area of the sphere. That means sphere is already created because of the changes in theta and phi by taking the constant r value. What is the surface area means whatever the ds value I have written here, this has to be integrated. So, I am erasing and explaining that one. So, ds r is equal to, due to the changes in theta, that is r d theta, due to the changes in phi, that is r sin theta d phi, you will be having in the radial direction, that is r square sin theta d theta d phi a r cap. Radius they have given as capital R. So, I am taking r square sin theta d theta d phi a r cap. Now, integrate this one. So, capital S is equal to surface area, that is nothing but surface area, integration of ds bar dsr is equal to r square is anyway constant, I am writing outside, integral theta, theta range is from 0 to pi and phi range is from 0 to 2 pi, sin theta d theta d phi we have to write, and a r cap we can write outside also, no problem. So, it is equal to r square. Next, sin theta integration with respect to theta is minus cos theta, limits are from 0 to pi, and integration of 1 with respect to phi is phi, and if you substitute the limits you will get 2 pi minus 2 pi r square, cos pi is minus 1 minus cos 0 is 1, that means here minus 2 you will get. So, it is equal to 4 pi r square. This is the surface area of the sphere, 4 pi r square. Similarly, you can able to get volume of the sphere also. Volume of the sphere dV is equal to 3 differential lengths we have to take, dl1, dl2, dl3. dl1 is nothing but differential length due to the change in r, that means dr. Next, due to the change in theta, that is r d theta, due to the change in phi, that is r sin theta d phi. So, what we will get here, r square sin theta dr d theta d phi. So, perform the volume integral, you will be leaving with the volume of the sphere. If you consider the radius of the sphere is capital R, integral r is from 0 to capital R, r square dr, integral theta is from 0 to pi sin theta d theta, integral phi is from 0 to 2 pi d phi. So, it is equal to integration of r square with respect to r is nothing but r cube by 3, limits are 0 to capital R, sin theta integration is minus cos theta, limits are 0 to pi, one integration with respect to phi is phi, limits are 0 to 2 pi. So, it is equal to minus r cube by 3 minus 2 pi. So, that is equal to 4 by 3 pi r cube. This is the volume of the sphere with radius capital R. So, in this manner we have these things. How I have explained about the differential volume in case of the cylindrical coordinate system. Here differential volume is created because of the change in r, change in theta, change in phi in case of the spherical coordinate system. So, this is representing the differential volume due to the changes in these 3 coordinates. If r is changing, dr is created, that is this one, this is r, this is r, this is one. After increasing the r, this is due to the change in dr, we are getting this particular side, that is represented with this one. Next, theta is changing, this is the first theta. Next, some more differential length, differential theta we have taken, that means we have changed the theta value. Due to that one, we will get what is the arc length change we are getting due to the change in theta, that is r d theta. This is the thing we are getting. When angle is changing, what is the differential length we are calculating? We are calculating the differential length due to the change in angle theta, that is r d theta. When we change the phi value, that means angle we are changing, what is the change in the differential length? That is what we are finding, arc length, that is r sin theta. This one we are calculating as I said previously. So, 3 differential lengths we have, so that this particular volume is created. So, this is the line we will get at an angle phi, and after changing the phi value, this is the arc length we are getting. Okay. So, this is the change in phi, that is d phi. Due to this one, how much arc length change you are getting means that is r sin theta d phi, that is what we have to observe. Okay. So, if you multiply these three dimensions, you will get the differential value, that is what we have seen previously. Now, finally, we have completed Cartesian coordinate system, cylindrical coordinate system and spherical coordinate system. Here we can able to see like a summary. So, in case of Cartesian coordinate system, the coordinates are represented with x, y, z, cylindrical rho phi z, spherical r theta phi. Here dl1 first differential length is dx, dy, dz. In case of cylindrical d rho, but when phi is changing, arc length we have to consider, that is rho d phi, and z is anyway distance, that is dz only, and r is also distance or radius, so that it is dr. When theta is changing, r d theta, when phi is changing, r sin theta d phi. This is the thing. So, here if you observe the scaling factors we can able to consider. Rho is a scaling factor, here r is a scaling factor, here r sin theta is a scaling factor. In remaining all cases, one is the scaling factors. Okay. So, volume element already we know, if you multiply 3 differential lengths, you will get the volume element. Next, the area element dA is equal to r dr d phi. R is changing, phi is changing in both coordinates when theta is equal to 90. This is about theta change. When theta is change, theta is 30. If you take theta is 90, that is representing the xy plane, that point already I have explained. Okay, when theta is constant, r should change and phi should change. So, how to get that particular circular area, that is based upon this particular thing only. Okay, and how to get that one? We will take that r value by taking its value changing from 0 to capital R, like that we can able to consider, and phi is anyway changing from 0 to 2 pi or 0 to 360. So, in order to get the total circular area, capital A is equal to integral dA, that is equal to surface area integral, actually two integrals will be there. So, that r is changing from 0 to capital R, r dr, and another integral is from phi is from 0 to 2 pi, that is d phi. So, it is equal to integration of r with respect to r is r square by 2, r square, and limits are 0 to capital R, and the integration of 1 with respect to phi is phi, limits are 0 to 2 pi. So, what we will get? Capital R square by 2 into 2 pi, 2 to cancel. So, here you will get pi square, pi r square. Like this we have the circle area. We can get circle area, we can get cylindrical surface area, we can get cylindrical volume, cylinder volume. Already we got sphere surface area, that is 4 pi r square, and sphere volume also we got, that is 4 by 3 pi r cube. And here one problem has been given, you can able to find all these things. Here it was actually given in the cylindrical coordinates, that is what we can able to observe by seeing the diagram itself. So, just I will give the points, some points regarding this particular problem. Radius is r, that is fixed, radius is r. Height is also they have given as h. Okay. And here we are observing two surfaces they have, okay, they have given some surfaces, S1 surface. If you take S1 surface, that is due to the change in phi and change in z. Like this you are traveling, that means phi is changing, and this length is related to z only. So, z is changing, that means height we are changing, z value is changing and phi value is changing. So, dz and d phi, these are the two things you have to take. If you multiply two differential lengths, you will get the surface area only, that is what S1. So, due to the change in phi, you will be having the length rho d phi, due to the change in z, the differential length is dz. So, S1 can be related to this one. Now, you see S2, S2 is related to this particular surface, it is related to the change in rho, because from here to here we have to travel, that is change in rho, and the height is also changing, that means z. So, S2 is related to change in rho, that means d rho, change in z, that is dz. Now, S3 is because of change in this movement is there, okay. In a angle wise we are moving, that means that is related to change in phi, d phi, but whenever phi is coming we have to keep scaling factor rho, and this is also related to the rho, that means d rho, like this, these are related. Next one is I think volume, this is related to, okay, V means volume here. So, volume is due to the changes in all the three lengths, d rho, rho d phi, dz we have to take, so that you will be leaving with this one. But here volume of not total cylinder we have to calculate, volume of this particular surface we have to, sorry, volume of this particular thing we have to calculate, whatever the portion of this cylinder, it is not complete cylinder. Complete cylinder means you have to take phi is equal to 0 to 2 pi, we have to consider, but it is not related to the complete cylinder, it is related to certain portion of the cylinder, where phi value is changing from phi 1 to phi 2, and z value is changing from 0 to h, that is what they have taken here, and phi value is phi 1 to phi 2, then only you will be leaving with this particular portion only. If you take phi value from 0 to 90, you will be having 1/4 of the total cylinder. If you take phi is equal to 0 to 180, half of the cylinder you will be leaving with. Okay. If you take phi is from 0 to 270, you will be leaving with 3/4 of the total cylinder. Like that, as phi value is changing, you are moving around that particular circle, and anyway this particular radius is given as 0 to rho. So, like that you will be having the volume of this particular total portion, some portion of the cylinder we can able to calculate like this, okay. That is the thing. Thank you. With this we have completed the topic coordinate systems.